Hello and welcome to my final year project demo, where I'll be showing my simulation prototype of a signal controlled warning system. I'll just start the software. The UI will load, and in the top left the user can enter their worksite location, which would be in real life a GPS location, and they can also adjust, set their warning time, which would be from the time in which the train will hit the worksite from when they receive a warning. So they might want more time if they need to move more stuff off the railway. And these are start and stop buttons for the simulation. And when you start it, the railway network is loaded from the database where its node edge graph is stored. This is based on a real railway network. On the left, stations aren't supported in this prototype, but on the left is Attenborough, and on the right is Nottingham, coming up to Nottingham station. And this is all based on real timetables and lengths of track. So the trains are simulated at the correct speed. The proportions of the tracks don't graphically have to be correct. It will work that out and realistically show the train's position. It uses the real lengths and speeds to determine where the train should be proportionally along the line, and the search algorithm is constantly searching from this worksite location back along the line until for a train within 30 seconds distance, and when it does trigger, it will update on the right here this warning status, which changed just then, so it should be 30 seconds now until it hits the worksite. This would be received on a field unit located at the worksite, and the system would be running on a office system. The office system, which would be located in a signal control center. And when it does pass the worksite, the alarm should clear, which it just did. And once the train's passed, the workers can safely get back on the worksite. I will just stop the simulation and show you the MySQL database, so I can show you the edge table, which stores all the edges. Their nodes, more importantly their speed limits and their lengths, their real life speed limits and lengths. There's also a nodes table, which just stores the nodes positions graphically, and a node link table, which is where the track switches are really defined, because if a node is a switch, then the three edges that are connected to that switch are listed here, so the system knows where to not only draw but also search down different lines. Okay, so I'm just going to start the simulation again with a different location. I'll put it at 60 seconds and start it again. I'll just explain how the search algorithm works. It starts at the worksite, and it initially runs one search to define some trigger points or strike-in points down the line, wherever 60 seconds would equal. Down multiple lines, if there are a switch, it would define 2 locations or many locations, and these points serve as a kind of point for the loop to recognize when to stop and start again, so the limits of where it needs to search to. So then once it's set those, it will begin its recursive search, constantly be searching, and up until those points, if it finds a train, it will update the warning, and if it doesn't, it will just keep it as clear until it does. Now, because the simulation doesn't know about switch settings or any signals at all, it must assume that this train here could reach this worksite even though maybe its route is actually straight ahead. And so to keep the safety integrity of this system, this prototype, it will warn until, if the train did pass this switch and didn't go up, then it would clear. It should clear once it's passed here, because then it knows the train can't reach it. So I will just skip until the train's a bit closer. Okay, so now the train has tripped the warning. The search algorithm can find the train, so it's red, and until it can no longer see the train, so you'll have to pass this switch here. Will it clear again? So in a second it should, the train will pass because it's going straight forward, and it should clear the system then, because it can safely say the train isn't going to reach there. Now in future versions of this system, simulation, it would be ideal for not only also stations but switches and signals to be simulated, so that the system can more accurately determine if trains will reach the work site, and also to just improve the realism of the simulation as well. But in this version it doesn't have any of those things included, so it must assume that the train could reach there. So yeah, that's this system. Thank you for watching. Have a nice day.